Saumya.
Hi, sorry about that.
No. You weren't too early. Like when I have students back to back, I let the next student in the room just so
Okay.
they know that I haven't forgotten them. So
Alright, I
then
wasn't sure if I was supposed to be there or not, so I kind of just left.
you panicked.
Yeah, basically.
It's okay. He was in the same grade as you, so it
Oh,
would have been great. So then it took me a little bit to get it. Anyway, just stay in the room. Like I was gonna say, hey Saumya, but it's okay. It's totally fine. So, how are you?
I'm good. How are you?
Good. How did the regatta? Is it a regatta
Yeah,
when you row? It's a regatta, right? Yeah. How'd it go?
that's good.
Yeah. Did you get voted most valuable regatta-er?
No, we don't
Why
have that.
not? Why not?
We don't have that.
Did they throw you in the river when you won? Did they throw you in the river?
Not me, but we don't really throw people in.
You don't throw the coxic, how do you say it? Coxic? Is that right?
Coxswain.
Coxswain. You don't throw the coxswain in?
I mean, we can, but we don't, because they'd probably get mad at us. So.
They're yelling at you the whole time. Am I right?
Yeah, I guess.
Yeah. Throw them in. Throw them in the drink. All right. What do you got for me?
So we're starting like this new thing at school, and it's like this
Problem solving thing?
Yeah.
Uh-huh.
And I have to share my screen because I don't understand it much, but it's like this kind of thing, and we have like my homework that I had like last week was on it. And I don't know what it
Was
is.
on using the thing.
Yeah, it's like this new thing that they're doing. Like you're gonna be graded on like how you get to the problem, and then I don't know.
Okay.
And then,
Oops. Wait a second. Why did that pop up? Sorry. Things are getting weird here. What's going on? Okay. My screen's acted funny. Sorry.
That's okay.
Okay, so, all right. Okay, can you make that a little bigger?
Like, oh, I don't know if I can. Sorry.
Okay, so let me throw this in there. Okay, and so now do you have questions?
Yeah, like it's like this kind of stuff, but it's like I don't know.
Okay, so how much what homework did you have to do?
It's this like 4 and then through 7, and then
Go ahead.
and then they want you to use like that kind of way to like figure it out, I guess.
Okay. All right, so I'm just going to get all of this on here. Don't move. Put it back down.
Sorry.
All right, hold on. Okay, no, don't move. It's picture time. It's like back in the 1800s. You cannot move. Freeze. All right, I got it.
Okay.
All right, so I will share my screen. And we'll get that there. Wow, how did that is really weird. What's going on? Oh, there it is. Okay, bonk. All right, so now I am going to put number 4 up just for us. And we got this. Awesome. All right. Yeah. Okay, so what is the real question we are being presented? What do you think, Saumya? What's the question? So for every single one of these, you have to identify. Is that right?
Yeah.
You have to do all of these.
Well, I mean, it's kind of just like, I don't know if you have to like write it out, but it's kind of just like how they want, like how they want you to like approach the problem, because there's people that have been getting stuff wrong and stuff like that. So I don't know. I don't know how to explain it. It's confusing.
So you don't have to write this out.
Not really, but it's like,
Okay, good. I thought we had to do every one of these for every single problem. It's just like a guideline of thinking.
yeah.
Okay. I feel better now. So we're solving for X, yes?
Yeah.
Okay, and what are you thinking here? What you got for me?
Well, I know that like the Pythagorean theorem is like a squared and then plus b squared is equal to c squared. So you know automatically that like your c squared is always going to be the longest side. So that would be like the x plus 1.
Okay.
You also know that you can either do like a squared is the x minus 7, or for b squared it'd be the x minus 7. It doesn't
That's good.
matter.
Because addition is commutative,
Yeah. And then
right?
it's just as long as one leg is equal to x and x squared, and then one leg is equal to x minus 7 squared, and then that all equal to x plus 1 squared.
Okay, let's do it. So x squared plus, got to put in parentheses, right?
Yeah.
Now the longest side is also the hypotenuse always, right?
Mhm.
Okay, just want to make sure you have that.
Yeah.
Okay. All right, so why don't you go ahead and expand these and let me know what you got.
Well, it's x squared minus 14x, and then plus 49, and then plus x squared is
Thank
equal to,
you. Good, keep going.
it's equal to x squared plus 2x plus 1.
Okay, so do you know how to do these?
This is like the farthest I went up to, because I just got confused at this point. Like,
Oh, here.
yeah.
Okay,
Like
all right.
I'm pretty sure I was supposed to like I have to set it equal to 0. So then I subtract like the x squared plus 2x plus 1, but I wasn't sure.
Okay, so this is no different than solving any other equations.
Mhm.
Okay, no different at all. So you're right, your instinct is right. And part of solving equations is we look on both sides and see if we can simplify either side or combine any like terms. So I'm going to ask you, are there any like terms on the left or right side that we could combine?
Well, on the left you have 2x squareds.
Yeah.
So it'd just be 2x squared minus 14x plus 49 is equal
Good.
to whatever's on the other side. 2x.
Good. And so you want to move all of this over. Are you able to do it all at once? Or do you do them one term at a time?
I think we could do it all at once.
Good. So I'm going to subtract x squared, and I get x squared. I'm going to subtract 2x. And what do I get there?
Negative 16x.
Uh-huh.
And
then I'm going to go ahead.
Sorry. It'd just be plus 50.
Okay.
And then equal to 0.
Good. Awesome. So now what in the heck are we going to do? We're going to.
Well, I have a feeling it's going to be like when you, like, because there's like no coefficient on the x squared, it's like you have to multiply the first and third term, right? 50x squared, and then you have to find like the factors of 50 that will equal the
Okay.
negative.
So what are let's list factors of 50 off to the side.
It'd be like 1 and 50, 2 and 25, 12 and 5. Oh wait, no, sorry, I don't know where that just came from. 10, not 12 and 5, 10 and 5.
Yeah, so I'll put 5 and 10.
Yeah.
Anything else?
Sorry. I don't know how to turn my messages off. Where's my life?
You can't turn off the program?
I'm gonna try and like turn the conversation on do not disturb. I'm so sorry.
It's okay. It's not your fault.
Okay. Hopefully that works.
Okay.
Okay. So
So, oh, wait a second. Wait a second. So somehow I did -1 here, Saumya, right? And it should have been +1.
Oh.
That's gonna make a difference, isn't it?
Yeah.
So I have to get rid of these factors because that's not gonna be it. And this, instead of +1, is going to be -1.
It's going to be 48 instead.
Yes, that is going to make a huge difference.
Yeah.
So -1 is 48. Okay. So now we're going to do factors of 48, aren't we?
Yeah.
All right, let's go.
You have 1 and 48. And
Yep, that doesn't work.
2 and 24 also won't work. 3 and 16, which I don't think will work either. Yeah. And then you have like 8 and 6, or 6 and 8.
Well, keep going. So 1, 2, 3. What comes after 3?
4.
4 is 4 factor?
Oh wait, yeah, with 12. But it'd have to be negative and a positive, like, wait. Or sorry, negative, because the
Yeah.
48 is positive.
Right. So we're good, right?
Yeah.
Awesome. So x -4, x -12 equals 0, right?
Yeah, and then you do it as like x -4 is equal to 0, right? And then x -12, like the null factor law, I think it is.
Yeah. Zero product principle, null factor law. X equals 4 and x equals 12.
Yeah.
Okay, so now we have to be sure we're talking about lengths here, lengths of sides of triangles. Am I right?
Yeah.
Okay, so and lengths cannot be negative. Am I right?
I don't know. No, they can't.
No. So if, for example, how far is about how many feet is that wall is the wall behind you from you? Just a guess.
Like 12.
12 feet. Yeah. Okay. 10 feet. We'll go with 10. Would you ever say, since it's behind you, would you ever say it's negative 10 feet?
No.
Never, 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 never. So length can't be negative. So whenever we're solving an equation and what it's dealing with length, we need to check to make sure that our answers make sense. So we need to plug our answers back in and see if they make sense.
Well, already looking at it, like, well, what I've been confused on, like, when you're trying to solve the answers, like, which x would you use, or would you use both? Like, plug each one in.
Check each one. Check them both individually.
Well, then you get -3, 5.
Does that make?
4.
Yeah. Well, you don't even have to do the other ones. Does -3 make any sense at all?
No.
No. So 4 is out of the club, not invited, Saumya. Nobody likes -4 or +4. Out.
So then 12, 7 is 5. You have 5, 13, and 12, which would actually make sense.
So we're good.
Yeah.
You okay?
Yeah, if one of like the possible numbers that you get for like x just doesn't make sense, you can just like cross it out, and then like they'll understand that the option you're like saying is
Yep.
okay.
Yep. All good?
Yeah.
Okay. All right. Are you copying, or do you want me to move
No,
on? Or?
yeah, we can move on. I have
Okay.
it.
Cool. So let's try B. Do you want to work it silently, or do you want to go through it together?
I think I can try it silently.
Okay. I will work it as well.
Okay.
But I will keep my mouth shut, which is hard for me to do, but I will. For you, Saumya, I will. And if you get it right, I am going to come over to your house, and then I'm going to pick you up and take you to the nearest body of water and throw you in and celebrate.
Okay.
It got creepy for a little bit when I said, come over to your house and pick you up. I know, but I think it ended well for everybody.
Yeah. Oh, I don't know. Okay. Okay, I got up to like the x squared minus 10x minus 45 is equal to 0 part.
Good.
And then I've been trying to work out factors, but I don't think, like, I don't know.
Yep. Did you list these guys?
Yeah.
And those are the only factors, right?
Yeah.
That's why it's important to just go up the ladder here. Try 1, then 2, then 3, then 4, then 5, right? And you see how these pairs are going down? 45, 15, 9.
Yeah.
So then the only other possibles are between 5 and 9, which are 6, 7, and 8, correct?
Mhm.
And they're not factors of 45. So we know we have all of them.
Mhm.
Okay. So if they're not going to work, what's our only hope? Our last resort?
Just wait. Factoring? I don't know. Like,
It rhymes with dramatic formula.
oh, quadratic formula.
See?
Oh, okay. And then you do that x is equal to the -10. Oh wait, +10, sorry. Plus or minus in the square root of -10 times, wait, -10 minus 4 times.
Wait a second, let's back up to -10. Something happens, this is
Oh,
negative b.
it's -10 squared,
Good,
or just 100 times 1 times -45. It'd be -10 times, wait, -10 squared minus 4 times 1 times -45 over
good,
2.
good.
And then you just get x is equal to plus or minus. It'd be the 100 minus 180 over 2.
It's not minus.
Oh, sorry. The -4 and the -45 would cancel out, and when you multiply, and it'd be 100 plus 180 is 280, and then over 2.
Good.
So then would it just be like x is equal to 10 plus or minus the square root of 140, or would? Oh wait. Would you have to like do 280 divided by 2 and 10 divided by 2, or
Why can I not do the 280 divided by 2?
Because you have the square root with it?
Correct. Only things outside of the square root can I divide by 2.
So then you can just do the 10 divided by the 2?
Well, I could, but then I would have to put a 1/2 in front of the square root of 280. Because you can't you have to divide both of them, right? And there's a 1 in front of the square root of 280. So what I need to try and do, if Mr. Y, I think he probably wants you to do this, is simplify the square root if possible. Okay. Do you remember how to do that?
Just finding the square root, but
no, breaking it down. I think we talked about it last time, where I try and think of perfect squares that are factors of 280.
Yeah.
For example, and I don't think of 280, I think of 28. And I know that 4 times 7 is 28, right?
Yeah.
So that means 4 times 70 is 280.
Yeah.
Right?
Yeah.
Does this ring a bell?
Yeah.
So then what happens to the square root of 4? What does it become?
It would just be the 2 like over the 2.
Mm-hmm.
The 70 over the 2.
All over the 2, right?
And then wouldn't you be able to just get rid of that 2 and it'd just be like 10 plus or minus like the square root of like the 70?
Well, you're kind of close, but before we talk about that, what we're going to be able to cancel out, we need to check on 70. Are there any factors of 70 that are a perfect square? Like 170, 235, 3 doesn't work, 4 doesn't work, 5 times something works, 5 times 14. Yeah.
No.
And then 7 and 10. So no, nothing works. So this square root is as simplified as possible.
Oh.
Okay.
So then,
Now, when you have a sum or difference divided by just one thing, you have to divide both of them. So
10.
Yeah, take a look at this. So when we have fractions, don't they have to have the same denominator to combine them?
Yeah.
So we're kind of backwards, right?
Yeah.
Okay. So that's why we divide both of them or simplify both of them.
So like you would group the number that's outside of like the square root with like the square root, and then the 10 would be like by itself basically. It's like,
Mhm.
and then the 2's cancel out on.
Correct.
Okay, got it.
So we end up with 5 plus or minus the square root of 70, yes?
Yeah.
Okay, so now I'm going to move back up here just so we can see the triangle again. We have x equal to 5 plus the square root of 70 and 5 minus the square root of 70, yes?
Yeah.
And this, what the square root of 70 is between what two integers?
Oh wait. Wait, the square root of like negative?
No, what are your perfect squares?
Well, like
Just generally. 1,
1, like
4,
4,
keep going.
9.
Keep going. 4 times 4.
16. So 16.
Next one, 5 times 5.
25, and then 36. 49. 64.
Okay.
81.
Okay, stop. Okay. So the square root of 64 is equal to what?
8.
And the square root of 81 is equal to what?
9.
And 70 is between 64 and 81, isn't it?
Yeah.
So that means the square root of 70 has to be between 8 and 9, right?
Oh, yeah.
That's what I meant.
Oh, okay. I got that.
So it's like 8 point something. And is it going to be closer to 8 or closer to 9?
Closer to 8 because.
Yes, because 70 is closer to 64 than it is to 81, isn't it?
Yeah.
Okay, so now I say that because we have to plug this back in and make sure, check and see what solutions are going to work, right?
Yeah.
Okay, so all we care is that they're positive. We don't care about the actual value, right?
Mhm.
So if I plug in 5 plus square root of 70, are all the legs going to be positive?
Yeah, I think.
Good, good. And now here's, and you could have also thought instead of the square root of 70, you could have said, okay, it's close to 8. I'm just going to try 8 and see if there's any trouble, right?
Yeah.
And 5 plus 8 is 13. Yes.
Yeah. Mm-hmm.
So you could have plugged in 13. You okay? Because 5 plus the square root of 70 is about 13.
Wait, how do we know it's 13 then?
Because we just said the square root of 70 is about equal to 8, isn't it?
Oh, right. Yeah. Sorry. And then it'd be
right.
8 and 5 is equal to, yeah.
Yeah. So that's about 13, right? This is 13. And what would this be about?
It would be 5 minus 13, so negative 12. Wait. Negative
So
8.
Yeah. Well, yeah. So it'd be 5 minus 8, right?
Mm-hmm.
Which is about equal to what?
Negative 3.
Okay. So we're going to plug negative 3 in here. Yes.
Yeah.
Okay.
And those would give you negatives because you already know first of all, if the longest side is negative 3 plus 7, and that's already shorter than the one of the legs, and it'd be a negative.
Well, negative 3 plus 7 would be 4, right?
Oh, wait.
Yeah.
But then a negative 3 plus 2 would be
is a
negative.
-1. Done. And then here's plain old x, right? It's negative. It doesn't
Yeah.
matter. Yeah. So we're going to cross out this guy.
Oh, and then when you're doing this, can you always just like what we did with like the square root of -70, like how it was closer to 8, can you always like substitute that in and just go off of that? Like,
Yes, but you got to be like, if it's really close, which it won't be,
mhm,
but let's say we didn't have an x there, and let's say, it was like, that's like -0.1, right? Well, that's close to positive, isn't it?
yeah.
So then you would probably have to get a calculator out and check, but they're not going to do that to you. They're not going to make it that close if you're not allowed to use a calculator. Okay.
Alright.
So I'm saying, yes, this will always work with a little asterisk by it. Like, just be careful, just in
Alright.
case you have some really mean people, right? Okay. So you want to try C? It's a
Yeah.
little different. This is a tough one to factor.
Yeah.
So why don't we stop and let me hear what you're thinking.
Well, I got up to the -4x part, like with the, and then -30, or sorry, the 4x part with the -38x plus 48, and then I just put that equal to 0.
And do you see how I factored out a 2 to make it a little bit easier?
Yeah, I wasn't sure if I could like do that, or if I needed to immediately like do the.
Absolutely. You can do that. In fact, what you're actually doing is you're dividing everything by 2 if you
Oh.
wanted to, and then you just have 0 equals the 2x squared minus 19x plus 24. But you can also leave it there. It doesn't matter. It's just hanging out and nothing's going to happen to it. So whichever you understand better is what you should do.
Okay.
You want to leave it or just divide everything by 2?
Leaving it's fine.
Okay, so now we have to factor. We can forget about the 2 when we factor this guy, right?
Mhm.
Okay, and so we talked about it last time where you could do the guess and check thing where these first 2 would have to be 2x and x, right?
Yeah.
And then you have to have factors of 24. They're the same, that when multiplied by 2 and by 1 are going to give me negative 19. Do you remember us trying that?
Yeah. But then
Or I showed you how to split the middle term.
like when we would have to have like 2 like separate equations when you break it
Mhm.
up.
Yep. Where I took the 2 times the 24 is the 48.
Yeah.
And then I looked for factors of 48 that combined to give me negative 19.
So like -3 and -16.
Yes. So we're going to rewrite negative 19 as 2x squared minus 3x minus 16x plus 24. Is that okay?
Yeah.
Okay. So now,
You'd split it up between like the 2x squared and the 3x and this -16.
okay, so well, you look at the first 2 terms, right? And what do they have in common?
An x.
Okay, and what am I left with then?
Just an x squared
How about a 2?
or 2x, sorry.
Mm-hmm.
And then -3.
Okay. Now,
And
same thing. Go ahead.
on the second one, you can pull out a 4.
You can
Or
do better than that.
-4.
You can do even better than that.
Oh wait, sorry, an 8. And
So
then
a -8, right?
a -8 because it's -16. And you just get 2x minus 3.
And if it's going to be factorable, then these will be the same.
Mm-hmm. And then
They have to be the same.
2 minus 8. Wait. Sorry, x minus 8. And then 2x minus 3. And then I have to set each equation equal to 0. So it'd be x
Yep.
minus 8 is equal to 0, as well as the 2x minus 3 is equal to 0. So it'd be so one x is equal to 8, and then the other is equal to 3/2.
Excellent.
So
So then we got to go back up, right?
yeah.
And 3/2 is 1.5, isn't it?
Yeah. So can you just say like 1.5 basically?
Sure.
So it'd just be like 2 times. Well, already that wouldn't make sense because the hypotenuse side would be a negative. If you were using the 3/2 one,
Mm-hmm.
but then I think the 8's the only one that makes sense because it'd be like the 24 minus the 7 is like the 17, but then the
Yep.
16, and then
Yep.
Yeah.
So this is out.
yeah. So the only
3
one.
halves is not invited to the party.
Yeah.
I am never invited to the party, Saumya. I'm just telling you. All right. So I feel like 3 halves right now.
Oh.
Okay. All right. So good. All right, good for you. So let's go see what else we got. All right, talk to me.
Well, I feel like because it's telling you that like the triangle, like you can draw it, I guess, like
Okay,
um, it's like if you were to draw a right triangle,
doesn't really matter. You don't have to draw it to scale, right?
no.
Okay, so here we go.
If you know that like the hypotenuse, like you don't know what it is, but you have the formulas for the legs, the hypotenuse would just be x.
So here,
Yeah.
okay.
And then one of the legs would be x minus 2.
Which one should I make it then? The longer one or the shorter one? Do you think? X minus 2.
Probably the longer
But
one.
by the way, yeah, the longer one, right? Because you're subtracting less. It doesn't matter. It doesn't matter, right?
Yeah.
But
yeah. And then that'd be x minus 7. And then when you're putting it into like the Pythagorean theorem, you would have to do like x minus 7 squared plus the x minus 2 squared is equal to just that x squared.
all right, let's go. Ready?
Yeah. I have like x squared minus 18x plus 53 is equal to 0, and now I'm pretty sure I have to put it into like the quadratic formula, but before I did that I didn't know if I was
53 is prime. You just go through your progressions. Like one, does one work? Yeah, but it doesn't matter.
yeah.
Just 2, no. Just 3, no. Just 4, right? They don't work. So
If nothing works, you just turn to the quadratic
yep.
formula.
And you can always turn to the quadratic formula. Like if it just gets to be like, I'm not sure, you can always use the quadratic formula.
Even if there is a possible like factor
Yep.
of it. Oh.
Yep. It'll just take a little bit longer, right?
Mm-hmm.
But you'll still get the same answer.
Good.
This is totally a calculator problem, by the way.
Yeah.
So feel free to use it.
I have x equal to, wait, how did the how did the 1 times like that 53? Oh, okay. Sorry. I messed up my numbers. I did it as 2x squared instead of an x squared. Like when I was doing like the 4 times 1, I did 4 times 2.
Saumya, I think that you should not do that.
Me too.
Or guess what?
Um,
I'm going to come over to your house. I'm going to drag you out. I'm going to pick you up and I'm going to throw you in the nearest body of water, but not out of celebration, Saumya.
okay. Well, then I better.
It will not be a happy toss in the water. Okay.
Okay.
Woo.
Okay. I got up to that, but I don't. I have a question about this. It's like when you're doing like once you like get the 18 plus or minus like the square root of 112, like that over 2. I feel like that's the step where I keep getting stuck on when I'm supposed to separate it because I just did like 2 and then the square root of 2 and the square root of like 56. Um, but I don't know.
Neither of those are perfect squares.
Yeah, that's why I feel like I keep getting.
Okay.
That's why I keep messing up. I don't know.
So you always want to divide by perfect squares,
Yeah.
right?
Mm-hmm.
And keep dividing. Now, you also have your calculator, right?
Mm-hmm.
This is a calculator problem. So you can take 112 and just start dividing by perfect squares. By 4, by 9, by 16 to see what the biggest one you can get.
Okay. What did you say? Okay. And for the square root of 7 part, like, can't I just like say like the 2 like square root of 2 square root of 7, like like the square root. Sorry, I don't know why this. It's just the most confusing thing.
It's okay. That's why I'm here, right?
Yeah, like I feel like I'm like able to get up to like a certain part, but it's like once it comes to like the like final steps of actually getting the answer, it's like I don't know what to do.
Okay, so are you okay with 9 plus or minus 2 root 7?
Yeah, I got that part, and it's because like the 16 can break down to like the square root of 4, which is equal to like 2, right? It's like,
Well,
Oh wait, no, it's 18 plus or minus the 4 divided by the 2 is
2, and that's why you get 9 plus or minus 2 root 7. So
Yeah.
you're okay to that point.
Yeah, but then once it's like actually getting to the answer, I'm like confused on that.
Okay, so now since it's a length, we have to plug in, right?
Yeah.
And all we care is that it's positive. Yes.
hmm
Okay, so 9 plus 2 square root 7. You plug those in, you can tell immediately that all the sides are going to be positive, can't you?
Yeah.
Because of the 9, right?
Mhm.
It's 9, and if I only had the 9, they would be positive, right?
Yeah.
And then you add in the plus 2 times the square root of 7. That's a bonus, isn't it?
Yeah.
Okay. Now again, it's a calculator problem, right?
Yeah.
So can't we do on our calculator 9 minus 2 times the square root of 7 and just see what it is?
Yeah.
And what do you got?
We get 3 like 0.70.
Okay. So it's whatever, it's 3.7, right?
Yeah.
Okay, so now just plug in 3.7 for the sides. You can do it in your head and figure out whether one of them is going to turn out to be negative or not.
You know that the one that's like the 7 centimeter one is gonna be the negative. Wait.
Yeah, so that's why we can cross it out.
Okay.
Okay.
Mhm.
So we know that 9 plus 2 square root 7 is the only solution, right?
Yeah.
And then that's A, that's exact.
So then, like, did you plug in like 9 plus the 3.7 then, or is it like?
No, I just on my calculator I did 9 plus 2 square root 7.
Mhm.
Go ahead.
And then that's where the 14.2 came from.
Right, right. So you know how to do it, Saumya.
Yeah, I don't know.
I think you get a little panicked.
Yeah.
Yeah. Okay, so that's in centimeters, right? Because everything's in centimeters.
Yeah.
And they wanted, I didn't put another M, they wanted millimeters. So we just need to move the decimal to the right and round it to the nearest millimeter.
Oh, okay.
All good?
Yeah, that makes more sense.
Okay, so I will send you these. Our hour is up, and I got another student coming in here. Remember when you came in? I don't want to scare her. And so I recorded it, and I think you like the recordings. You do want them recorded or no?
Yeah, it's helpful.
Okay. Okay. So it'll take me a little bit because I've got another couple of students, but I'll get them up. I'll get it up there for you. I'll send you the notes as quickly as I can as well. Okay.
All right, take your time. It's all right.
All right. Be good.
All right, thank you.
Bye.
Bye.